All right, good morning. Here is a video to help you write a basic programming code for an engineering problem, which will help you with homework too. So here we have a motor, has an input power of 100 watts, and is connected to a flywheel. We're trying to find how long in hours must the motor operate to transfer 300,000 joules to the flywheel. We're going to assume the process to be 80% efficient. So again, in all engineering problems, you'd have givens, assumptions, sketch, nomenclature, and what we're looking for, and and then finally the solution. Okay, so when you're doing these problems, sometimes it might be helpful to do it on paper first to match your programming script. Okay. So what I did is I just kind of went through and showed you the equations that we're going to use. Okay. So the first thing we need to do is we need to find the output power based on the input power and the efficiency. Okay. So basically what you have is, here is a motor, plus, minus. Here is the shaft, and it's hooked to a flywheel. Okay, so this is spinning. So what we have is input power, and then we have output power. Oh, sorry about that. Okay, and I put the dots to indicate that it's power, not energy. Okay. And then this actually, let's do red, should have, releases heat to the atmosphere, and that's why it has an efficiency. Okay, so the input power is always going to be higher than the output power because you have heat generation. So the fundamental equation is efficiency is the output over the input. So I just rearrange that for the output power. Okay, and then we know that output power is actually the amount of energy per time, so we can just rearrange that for delta T. Okay, side note over here, when I put a dot in front of stuff, it's joules per second, it's a watt. Okay, it's power. And then if I just have no dot, that is your energy. Okay, so what we're going to do is I'm going to program this code with givens, and we're going to calculate the amount of time it takes for the operation. Okay, again, engineering problem. How do we do this? Well, let me show you. Okay, I'm going to put my Octave code here that I have. Let me make this bigger for you. There we go. Okay. So at the top, you have all of your header file. Okay. Always have this, no matter what. Okay. Trust me. In a few years, you're going to go back and you're going to be like, this has been very helpful to figure out what I was doing in this assignment. Then I have nomenclature. Okay. So W out is output energy. W dot, output power, efficiency, input energy, input power, and the time, or the required time of operation. Okay, now all of these, anytime you do a problem, you should always have givens that are numbered base. Okay, and you can change these numbers in the givens and it will change the results. Okay, so don't hardwire a number. So what I mean by that is, do not put 0.8 here, because say we want to change the efficiency, all you need to do is change it here. Okay, so what I like to do is I like to put like lines through these, so I know these are the things that I'm changing, that I could change. And then everything below this in the solution is either variables, or in this case, I'm just converting to hours. So those are always going to be the same. Okay, so don't hardwire numbers. Make them in terms of givens. So I have the efficiency, I have the input power, and I have the output energy. Okay, those are my givens. And then what we're looking for is first, under the solution, find the output power. So the output power is going to be your input power times the efficiency, just like I showed you. And then we can find the time by taking that output energy and dividing it by the output power. Okay? And again, I put semicolons on all of these so it doesn't spit it to the command window. And then this is actually in seconds, so I should put the units on here. These are watts, and this is then hour. Okay, so I have three equations here which kind of correlate to 1, 2, okay, and then the conversion is the third one. Okay, so you don't have to write all of these steps. Write the main steps. Okay, break it down into simple equations because it's easier to debug later on. Okay, now I haven't taught you this, but there's a cool command called fprintf where you could spit this information out to the command window, and we're going to talk about that in the later assignments, but I just put that in there. Okay, so let me run this and I'll show you. So go up here, hit run, go to your command window. We'll go here. Oh, what happened here? Let me go back to here. Let me run it. Okay, so right here, operation time is 1.04 hours. Okay, so that right there. And now you don't need this fprintf. You could right here just suppress this and run it again, and it will spit it out to the answer. And I'm okay with that right now, okay, because I haven't taught you fprintf. But this is a very simple engineering problem that you can then program. Now the cool thing is, I'm going to put this here, we could just go ahead and change the efficiency. So say the efficiency is 50%. Well, what do you think do you think it's going to be take longer or shorter? Well, if it's lower efficiency, it's probably going to operate more because you need it to last longer. So yes, so 1.67 hours. And if it was more, it was closer to 1, then it would only be 0.93 hours. Okay, so that's why I like having the givens up here, because you just change that and it changes everything. Now what you're going to do in homework 3 is you're going to plot. So you can make a matrix from 0 to 0.1 to say 1. Okay, so every 0.1 efficiency, we're going to look at the data. Now I don't know if this is going to work. We may have to put dots here, and we'll talk about that in homework 3. And I'm just curious to see if it will. Yep, perfect. So it kind of spit out infinite because you're divided by 0, 8 hours all the way down to 0.83 hours. Okay, and then what we're going to do in homework 3 is we're going to plot. So you could plot a figure. You could plot E versus dt hour. Let's make it a solid line that is red, and let's make it line width 2. And homework 3 goes through all of this. Okay, and I'll show you how to do the axis titles and stuff. But look, now we have a graph that shows the relationship. Okay, well, I hope this helps. Please don't hesitate to ask if you have more questions or you need more videos. I'm always here to help. Thank you and good luck.